This is the Brain Chip Podcast. Hear from our thought leaders about neuromorphic computing, beneficial AI, and how BrainChip's Akita is pushing AI to the edge. This podcast is a place for investors, practitioners, and anyone interested in the future of AI.
Hello, everybody. My name is Hehir. I'm the Chief Executive Officer here at BrainChip. And today for our podcast, I've got a very special guest. Dr. Eric Gallo is a Technology R&D Senior Principal at Accenture Labs, working on next-generation computing technology along with sustainable smart electronics and materials for edge intelligence. Eric has a PhD in semiconductor devices, electronic materials with a concentration in low-dimensional devices. He also spent 7 years designing and prototyping body-worn situational awareness enhancement systems for warfighters and astronauts using augmented reality and computational vision. Eric, welcome to the podcast.
Thanks for having me.
You know, I always like to begin these podcasts in a very casual way and assume that not everybody here knows about your company. So if you would share a little bit of information about Accenture, an organization I have a great degree of respect for, a little bit about yourself and your role in the company.
Sure, happy to. So I'll start big and go small. Accenture is a global professional services company with roughly 750,000 employees worldwide that provide services and solutions in strategy, consulting, technology, and operations. I think the most exciting part for me is that Accenture places a really strong emphasis on innovation and bringing the best new technology to clients with a deep understanding of how it's implemented, the best practices, and everything's necessary to make these new technologies work. And that's kind of where I come in. I work in a small group called Accenture Labs, small in relation to the rest of the actual company, called Accenture Labs, which is part of the broader innovation organization. And in Labs, we're exploring emerging trends and technologies that range from Gen AI to smart materials, and working on refining them and bridging the gap from, say, academia to actual commercial, practical, real-world solutions. I specifically work in a group that's called Future Technologies, where our objective is really creating intelligence everywhere. And this includes, investigating and looking at technologies like Neuromorphic, but also extends to things like smart materials, biodegradable electronics, advanced manufacturing, energy and energy harvesting. And specifically, I lead the initiative that is the Next Gen Compute, which does most of our neuromorphic work. But this also includes looking at analog computing solutions, photonic computing solutions, and other pieces like that. My background, as you mentioned, actually gives me the great opportunity to really work across all the different spaces in my group, working on smart materials, biodegradable electronics, energy harvesting, and everything like that. So I get my hands in a lot of stuff. So it's pretty nice.
Great. You have a fun job. You're a very interesting job.
I do, in fact, have a fun job. A fun job that, I get to do most of the time from the comfort of my own office in my home. So it's extra special that way.
That's great. That's great. Of all the things you said, though, one of the things I always love about Accenture is what you said in the early part of your introduction to the company. I always think of Accenture as being a forward-thinking company on technology, but they always focus on the business impact of it, really, which is the impact it can make on their clients. Because, I mean, obviously, we're an organization that creates technology to create impact for our customers. So I love that comment. Let's go ahead and start getting into a couple of questions here. And I'm going to mix up the order for some of the ones that I sent to you, which is, let's start with neuromorphic, something I know you very well about, that you know very well. Let's share your view a little bit about neuromorphic technology, the benefits and how that could work, your long-term view. Do you see it being mainstream use cases, wherever you want to go, but just give me your view of neuromorphic technologies.
Sure, happy to. Actually, I'll go back to something you mentioned in my bio, that 7 years that I spent building situational awareness systems for warfighters and astronauts and firefighters and EMT. And in that goal, what we were trying to do is sort of leverage all this emerging technology, smart sensors and augmented reality displays, and the fact that we can do night vision with a bunch of tiny cameras and all of these pieces, and sort of put them on the body of the people who needed them on the go. We designed things for Air Force and Army, for deep space flight. A lot of work we put into firefighters. And in that time that I was there, I really became the systems engineer. I don't know how, it just sort of happened. It's a small town in Vermont, not a lot of people around. And I constantly would look and see the potential of what we could do, what we could put on the body, how much intelligence that all of these individuals could carry around. But I constantly ran into that power issue. It's like, I have it, I can put it on you, but in order for me to get all this to work, you're going to be pushing a wheelbarrow with a battery. And that's really what brought me to Neuromorphic, is taking a look at what these capabilities are, that I could do the same amount of neural processing I was doing on some of the sort of specialized chips that we were using for our designs. But I could do it for a tenth of the power. And tenth of the power when Neuromorphic is still young. It's still, it's still on its growth curve. So the expectations that I have really are that we're going to see in practical implementation 100,000 times improved power. And that opens up this amazing realm to keep people safe. To really, my specialty at that company was situational awareness, which is just basically pulling in information, figuring out what the user needs to know, and giving them their minimal information display. So it's not distracting, but when they need the information, it's in front of them. And Neuromorphic is, to me, the best current technology to really enable that. But in my time at Accenture, I see it in so many other spaces. I see it as, for distributed sensing, for rigging up a home so that you can have, your house can almost become alive. You've got sensors everywhere. It can talk to you. It can tell you what you need. But you don't need to tear out all your walls to put in infrastructure so that you can have power to everything. Because Neuromorphic can do this on energy harvesters or do it on very small batteries, such. I see it very much as like the eyes and ears in factories, which can enable you to rapidly modify. I mean, one of the situations that we know is that a lot of production, it's not these factories where there's these static machines that are just placed in one spot and they never move. These factories are being rearranged, and being able to sort of rapidly take smart sensors and use neuromorphic computing and its low power potential to sort of like just rapidly rearrange so that you have a constant awareness of what's going on, I think is another key thing. The last thing I would sort of pontificate on, which I think is I will say is probably my opinion and not even my group's opinion, is that Neuromorphic also offers this really unique platform that when you take a look at practical devices, the most of the embodied energy of sorts is often in the interfaces. It's connecting everything together because everything speaks a different language and you have to translate it and Neuromorphic really has this potential by just, going to spikes or going to very simple modes of communication to make integration of everything quite seamless and quite simple, to the extent that you could build biodegradable simple neuromorphic devices that then could communicate with the Akita directly. And you've eliminated a lot of the infrastructure costs that it takes to implement these new technologies.
That's great. That's great. Well, let me dovetail on your comments a little bit about that simple integration, the power savings, and use cases. I believe, and I love your comments or your thoughts on this, that's what makes it uniquely well suited to serve the edge market, right? And take computing everywhere, like you said, next to the sensor. Give me your quick thoughts, if you will, about where we are as an industry about edge computing? Early days, mid days, late days? What's your view?
So I'm much more of a research scientist, I think, than in the mix of where edge computing is really being implemented. From what I know, like we're over the peak of inflated expectations in terms of edge. We're on our way towards the sort of practical systems where it's going to be, ubiquitous and used everywhere. But one of the things I think that I see is like this emergence of an understanding that it's going to take a heterogeneous set of computing devices to really accomplish the goals optimally. I think that's an opinion that's been expressed by Cloud First within Accenture that deals a lot with edge computing, and that's, I think, one of the things that's really exciting to me is that, I don't think von Neumann computing is going to go away, but I think it's going to give way to allow a bunch of other players that can do things better in different situations and different spots. And that you start to see this almost continuum, where you have architectures that thrive at the edge, architectures that thrive in the cloud, and then, others that maybe fill in betweens and other spaces like that.
Yeah, no, I couldn't agree with you more. You use the word heterogeneous computing. I like to say it a little more simple, the right tool for the right job, right? And I've been in the industry a long time, and things go back and forth, centralized models, decentralized models, of compute. But you realize the right thing is to get the right amount compute next to the job, wherever that happens to be. And it's usually a blend of the two that usually settles on traditional workloads. In our practical experience, actually on the edge right now, to your comments, your opening comments there, is all companies with edge devices are examining their strategy with AI right now because they feel and they know they will be left behind if they don't offer some capabilities there. Computing is there now, but the ability to do inference very close to the edge is something that all companies that we serve are examining. So, interesting phenomena.
And with the rise of Gen AI, artificial intelligence needs information, and there's going to come a point where we, there's only so much information you can train off of YouTube and other spaces like that. We're going to want real-time information, but we don't, just like we do for our own brains, we don't want to read the binary code coming out of our watch. We want to read the time. And Gen AI could be the same thing, where neuromorphic is just what's giving you the time, or neuromorphic is sort of collecting the data and giving the key parts that are necessary for, Gen AI in the cloud, or maybe even potentially, running Gen AI itself.
Absolutely. All right, let me shift gears a little bit. You recently wrote a blog about space. Can you share a little bit what's Accenture doing in space and what you wrote in that blog?
Sure. I say that, we in labs, just like I said, we deal with intelligence everywhere, intelligence at the edge, and the furthest edge you can think of at this point is space. And when we really look at what's been happening in the way things are designed in space, I think most people will be surprised how little intelligence is really in space, aside from, the astronauts themselves. But that there's not, our satellites aren't smart, not in a way that we've almost become accustomed to dealing with in our everyday lives. And part of the reason for that is power. So we really see neuromorphic as this pathway to making, satellites, making other devices in space smart without the enormous impact of energy and thermal dissipation and other things that most other existing technologies require. So that's really, our view. And, and we're working right now, and hopefully we will accomplish it towards, sort of demonstrating some of this real time with a neuromorphic board.
That's great. That's great. Yeah, and as you know, we have relationships with many space organizations around the world, and the interest is incredibly high right now.
Yeah, it's
I know. What's that?
I was just gonna say, I feel like it's like this a sudden wave has come over where everyone's like, wait, what are we doing? Why haven't we done this yet? Like we have this technology. Why aren't we making things smart? Like because it's certainly not inaccessible at this point. It's just sort of uncharted to a large extent.
Yeah, great comment. So I've known you now for, I don't know, a year and a half, 2 years. You had a chance to work with brain chip technology. Any comments you want to make about our company and the tech, what you've seen?
Sure, I'd love to. Yeah, so Akita was the first piece of neuromorphic hardware that I personally became involved with. I have to admit, I'm not a coder. I'm mainly a project manager and help come up with what we should be testing and those sort of things. A teammate of mine, Noah, is the one who does most of the actual coding. But I can say that, we've had wonderful success, like really, really solid, healthy success in our work that we've been doing with Akita. We did some efforts, I think I mentioned in the blog, where, in a practical real world system, not just a sort of a lab where the chip is measuring its own power, in a real world system, we saw a substantial drop in power draw for a full PC attached to an Akita, running an audio neural network. And we compared that to various other things. And, we see that, I think it was roughly a quarter or a fifth of the power for the total system from the wall power that we saw. And, we take a look at that because we're very interested in practical real world systems. What are these things going to do when we put them on the factory floor, or we put them in a satellite? And those initial results were really promising. I could say that, you are definitely one of our favorite companies to work with. You guys are amazingly supportive, like always willing to chat, always willing to help us out, and been truly partnered with us in our efforts. And when the results weren't exactly what everybody wants them to be, we're okay with that and figured out, like, okay, what do we do? Where do we go to make it better?
Great. Thank you for that comment. Well, thank you. That was kind. All right, we're getting ready to wrap, Eric. I'm going to give you the last word. Anything you want to comment on at all about what you see in neuromorphic or computing or anything at all?
Probably could talk for hours about this stuff, but I think I just go back to, I think one of my real excitements is that the neuromorphic architecture, if you look at it as an architecture, just offers this possibility to sort of span material spaces, to span, from, the potential of making tiny little biodegradable neurons that maybe are in a sensor that's in your water, so that you can tell you whether there's bacteria there, and then transmit to, another small neural network that'll say, whether we need to panic about, all the way up to, this amazing work that's being done, like with, Spike GPT and all of these sort of large scale efforts that they're having. I just think the whole thing is really exciting. I think there's a lot of space for anyone, even who's not necessarily an expert in computing architecture, to get involved and really understand what they can do and how they can contribute to the overall effort.
And so that's a great way to end this, because what we strive for here at BrainChip is breakthrough performance, whether that's performance measured in FPS or power, as you mentioned earlier. But we certainly want to make it practical and easy to adopt and easy to consume and easy to implement. So that's certainly something we will never stop pushing on, to make it the easiest to consume. Eric, I want to thank you very much for this, and I want to thank our listeners for tuning in today. As always, it's a fascinating time to have a conversation with you. Have a great day.
Thanks.
Thanks for listening to the BrainChip podcast. Please remember to rate and review on your favorite podcast platform.